comes to the VinAI research seminar. So today, it is our pleasure to have Phuong-Hoa, who's actually working at the Microsoft AI team in London, and she graduated from Imperial College. And today, she's going to tell us about the challenges and opportunities in natural language processing in perspective from the East. Okay, so welcome. Thank you.
Thank you everyone for coming, and thank you VinAI, and of course thank you Sun for coordinating. Today, the main topic I want to focus on today is challenges and opportunity in natural language processing, perspective from the Earth. Why the Earth? Because so I'm working in intelligent input team of Microsoft, so it's in a small team within Microsoft AI and research team. We focus on a lot of different problems in NLP, like text processing, text predictions. But one of our main focus recently is related to East Asian languages, and I think it's very, very much relevant to the context of Vietnam in specific, and also in a larger context that we want to tackle a bigger problem related to East Asian languages, Thai, Vietnamese, Indonesians, all sort of different language that's not Latin script. Okay, so a bit about today's agenda. What I'm trying to achieve within today, an hour today. First, a bit about myself and some disclaimer. I work for a big company, so we need some disclaimer before we go on. The second thing that I want to cover is NLP, and why it's such a complex and beautiful area. I know that most of you here may already know about natural language processing, practice in that, have some experience in that, but I just want to give some people the reason to care about NLP. The third point, highlight about what I know. NLP is so broad, and maybe it's been difficult to get everything started. So I want to focus on the main areas that I myself have experience in, text processing and language, low-level language modeling. The final point is some discussion about NLP in East Asian languages. We are in the spotlight and a lot of advancement in recent technique of NLP actually have East Asian language a lot, and we may just achieve something big in the future, and it won't be all part of it. Okay, so a bit about myself. Anh Hưng introduced before, then I mentioned in the beginning of the seminars, I'm a data and applied scientist in Microsoft, but I want to call myself a statistician in disguise, and I love linguistics. That's why I choose NLPs. I'm not a PhD. I mean, it's typos. You cannot be an NLP seminar without typos. So, the main job I'm doing is my hands are really dirty. I focus on text processing and low-level language modeling. NLP can do a lot of other things like machine translations, like text classification, but my focus is on text processing and low-level language modeling. I specifically choose NLP as my career path, because for me, we should use artificial intelligence to solve natural complexity. Okay, so NLP is natural language processing. That's why. So I chose a quote that I really like in a neural network methods in natural language processing book. Is human language is highly ambiguous. It's also changing and evolving. People are great at producing language and understanding language, and are very capable of expressing, perceiving, interpreting very elaborate and nuanced meaning. At the same time, why we are human are great users of language. We are very poor at formally understanding and displaying rules that govern language. So, in general, NLP is a field that is evolved, is messy, is very human. So it is a very, very complex field to start with, and East Asian language add another level of complexity in that. Okay, so I have some questions to just warm up to help you understand a bit about how complex the natural language processing can be. Anyone know which language has the largest alphabet in the world? A lot of Chinese. Any other idea?
Japanese.
Sorry? Thai, Japanese? No.
Arabic.
Arabic? No. Okay, it's a Khmer, so it's Cambodian language. It has 74 characters in the alphabet. And it's also one of very complex language that we need to solve. Language have the biggest number of native speakers. This one is easy. Yeah, Chinese. Also East Asian language. Which character only appear in French loan words in Vietnamese? No, character. What character that only appear in French loan words in Vietnamese language? We are all Vietnamese, I suppose. F, yeah, one of that. Another. Something that we think the Vietnamese is not very Vietnamese. Okay, it's letter P. So in fur, film, and all of that is French originated word. So you all know, so you can see that is how natural language processing can be a very complex problem, right? One language that's very close to us is actually Khmer. Cambodian have 74 characters in its alphabet. Imagine what kind of combination that it can generate from that 74 character. Sorry. History of NLP. So NLP actually a field that started 50 years ago. And it's come to up and down. It's like all other AI techniques. It's had up and down. It started first in 1957. In order, so Noam Chomsky have a book called Syntactic Structure. And in this book, he tried to argue that if you want the machine to understand you, you need to change your structure of grammar. It's not the right way to do that. So in 1966 is AI winter, along with AI, NLP also suffered from a very bad time here. In 1980s, statistics become a dominant force in NLP. It means that NLP become less rules-based. Before, we need a lot of linguistics try to model and come up with a rule of language to do language modeling. But in 1980s, become more statistic driven. So that's the point that we need NLP become less rule-based and it's become more and more statistic driven. And that's why it's become a big jump of performance from that point of view. In 1990, we start having a lot of language online. We will start modeling NLP become super popular. In 1997, LSTM come to play, which is very, the first paper about LSTM come to play. So long short-term memory come to play. It's become a big giant jump as well. And 2011, we have Siri, which is one of the first NLP products that is widely used in commercial landscape. That people can actively use that kind of machine. So I just want to highlight this kind of history of NLP because I want to highlight one point that it's very interactive relationship between human and machine learning in NLP. NLP is basically a very human part of AI because we need to learn from human and human actually learn and all the human language evolve from that. Just imagine when you see a lot of word online and you start learning new word and start combine new word. Like every time I come back to Vietnam, I feel that I don't understand a lot of Vietnamese word because it changes over time and then people come up with new words all the time. So it's why NLP needs to be very elastic and dynamic in order to tackle all that problem, especially in a young and dynamic environment like East Asians. So I borrowed a slide from Log Techniques Microsoft. So it's a very common NLP architecture approaches. I think this is a project that they try to build a library to do parsing in medical paper abstract and come up with some kind of entity, do some kind of entity clustering and classification of that. So it's very common architectural approaches when we have text processing, word embedding, training phase of label training data and label test data. It's very common technique. What I want to highlight here is two steps. Devoice in the details. There are two steps that are actually very, very important when we do NLP. That's normally, it's not normally. Sometimes that's a kind of undermine to like kind of small dirty stuff. For example, text processing, like a lot of actually in the modern time when a lot of like English library words available online open source, so it's very easy to do text processing, like it's using NLTK, using very simple stuff in PyTorch or TensorFlow, and you can do text processing very easily, tokenizing things. So it seems to be very easy to do text pre-processing stuff in NLP, but actually for each Asian language is super important of this stuff that you need to do the text pre-processing right before you do any machine learning technique, or else it's going to be a disaster. Okay, so language model is a bottom layer of that. One of the very famous quotes that I really like, that you shall know the nature of a word by the company it keeps. That's why we need a language modeling. Language modeling, you actually try to predict the next word based on the first word that people type. It's a probability distribution of word. For the very initials and simple model, language model that everyone may heard about is Ngram. Now we have some, in recent years, I think in 4 or 5 years, we have a big advancement in NLP technique when LSTM and RNN neural network come to play, especially when attention mechanism come to play in 2015. It's become kind of sensation in the whole NLP community because it really brings an advancement in performance and also the mindset of the researcher, I think, because you really need to think about NLP problem in a different way. Okay. What I want to highlight is how different behavior actually affect how we build language modeling. Anyone of you here type in the way that you type something, and you look at the candidate bar, and you choose a prediction that fits your typing, and then you click on that instead of so you don't need to type the whole word, you just need to look on the candidate bar and choose the prediction from the candidate bar. Any one of you here type in that way? So 1, 2, 3, 4, 5. Yeah. So we have like 5 in roughly 1% of what maybe 10, 5% of what people in how many people in the room actually type in that way. But you will be amazed about how many Japanese and Chinese users actually type in that way. So in our team, we call it hand and pick behavior. Because Japanese and Chinese is just so complex and so long that you actually type and try to look for the right candidate on the candidate bar, click on that, and you do tail editing. So you actually edit back to the word and change it to the word that you want. It's even save you more time than you type the whole word because it's just so complex in Japanese and Chinese. Another question, what if I hope any of you, all of you here also have like basic understanding of about NLP. So before we do any kind of NLP technique, we need to clean the text. And one of the things that we do is we tokenize the word, right? You try to tokenize the word so you have the word, for example, a paragraph, 15 words, and you pass this into a bag of different words. So that's the first thing that you do when you do any NLP thing. But what if the space delimiter is not the weapon anymore? Where is the space in Thai? Where is the space in Chinese? And where is the space in Japanese? It's basically no space. And in Vietnamese, we have space everywhere, basically. So when you see hạnh spaceful, so you cannot just delimit between the two words. Hạnh phúc is actually one word. So what I want to highlight here is definition of token and definition of word, also very diverse among all the languages. So it's really hard for you to, for example, we normally very familiar with the word tokenizer, but what do we mean by tokenizer is also different among all the languages. Another point is that language keeps changing. So the problem that we are facing in East Asian language is also applied to some specific field. Like, for example, that's why a lot of work that Microsoft is doing is actually focused a lot on medical research, because medical research is also a field that feels like a foreign language. They use English, but a lot of jargon, a lot of abbreviation, and you cannot use a normal technique, a normal approach that we normally use with conversational English to do that. So so it's also a different behavior that we need to bear in mind and have a quite customized approach for that. Okay, so we can have a simple modeling comparison. So normally in NLP, we all have, for example, you have to correct the spelling mistake and predict the next word, for example, is a normal job for all the NLP people try to do. So in English, it's obviously a misspelling mistake. So we try to correct it into today. But it also can mean that some people name Sudia. So but you have two options here, basically. That's a misspelling word, and you correct them to today, or you keep it as it is, and its name is Tudia or something. Another example is people try to type in Vietnamese, simple 4 character. It's a teletyping typing. So it's maybe a misspelling, and we think it had. What about the next words? We try to say it may be hạn mức, so it hạn hán, or maybe they didn't finish their typing yet, so it may be hạnh. And then when you have hạnh, what is the next word? It can be hạnh phúc, it can be hạnh nhân, but also not finished. It also can be hạng, or it also can be they also misspell the last word as well, so it can be hạng. So yeah, so that how complex the Vietnamese can be in modeling. And Vietnamese actually still Latin script, but if we have other problem with Chinese and Japanese, and also other language is not standard Latin script as well. Okay, so that's all the things that I just said. It's just I want to highlight about how important of tech pre-processing gonna be. So tokenization is built in the base of the story. Story of Japanese, Chinese, Thai, Vietnamese, challenging in different way. Japanese, Chinese, Thai, no space. Vietnamese space in middle of the word. So we have multi-words tokenizations. Technical field, jargon, also kind of foreign languages. So, the solution that normally we have in the field is we try to do a stochastic tokenizer. So I just mentioned with Sons in the beginning of the session that we basically need to code the tokenizer from beginning in many different languages, just to make sure that we have the best tokenizer in place. to do the pre-processing before we do any NLP techniques. For stochastic tokenizer, specifically in Vietnamese and Chinese, we have some common technique that we normally employ. One is dictionary matchings. We try to search from, for example, trigram. We know that the maximum compound word that we have in the language is 3 words. 3 tokens in 1 word. So we can try to map that and then keep searching before we know that if it's not trigram, so it may be a bigram. It's not bigram, so it's unigram, and something like that. So it is searching that we can do. Another very advanced technique, recently a lot of paper mentioned about that when we do stochastic tokenizer, is conditional random field. So it's become a very powerful technique recently. There's a lot of papers that mention about it. If you want to know more about stochastic tokenizer, so actually you can see this word come up a lot about conditional random field. So anyone interested about this technique, so I can mention it later. Hidden Markov model is more general model of conditional random field, but for some languages that have limited training data, so we also can use a hidden Markov model for the stochastic tokenizer. One of the models that I really want to highlight here is recently a lot of papers and a lot of research mentioned about character-based model. It's really a perspective from the earth. So previously, there's a lot of NLP model. They use word-based models or token-based models, but because of some complex language like Chinese and Japanese, when people use a lot of character-based typing behavior, so we recently come up with a lot of papers that people employ character-based models to do some of the text classification and even do the tokenizer in character-based models. You can see on the screen is one of the graphs that I borrowed from UBC Wiki, it's University of British Columbia. They have very good kind of modeling, illustrating around all the steps around character-based models. It's quite similar to the word-based models, but we start with character. It seems to be quite simple, but even you remember in the previous slide I mentioned about attention mechanism. So attention mechanism is also a state-of-the-art, one of the state-of-the-art approach that people use in NLP models. If we use attention mechanism in a character-based models, you can see that attention actually comes at a cost, and it's very costly to do an attention mechanism in a character-based model. So actually, that's why we kind of in a commercial landscape that we try to optimize the cost a lot when it comes to character-based models, because it can be very expensive. You can imagine, for example, for a combination of input-output of 50 input, and you want 50 character input, and you want to produce a 50 character output. It's already kind of how many? Let me try to put out the equation. Yeah, so it's around 2,500 attention value. So it's actually very expensive in computing already. So that's why this is very advanced technique in when we want to model some languages related to very complex Asian language like Chinese and Japanese, but it's also very expensive thing to do. So we need to consider and optimize the cost a lot around that. The last one of the final steps that we want to do is of course, after you build a language modeling, you want to evaluate a language modeling of Asian language modeling from an Asian user point of view. So that's why we need a specific set of metrics that also track the user behavior when we have a language model that's specific for each Asian languages. For example, we have speed, character-based error rate. That's all the metrics that should be measured in character-based instead of like we normally have like net token per minute or something, or edit rate per 100 token. That's a normal metric that I often see in a normal language modeling in Latin languages. But if in Asian languages, we may need to switch it into character-based in order to really capture what people want. One of the metrics that I find very interesting, I saw in some of the Japanese evaluation paper that they use is character-based error rate. That means they compare the input and the output, and then make sure they capture the effort in between, how much of the effort that people need to insert. For example, they need to insert 10 characters, and they delete the last 2 characters, and then they insert another character to finish the word. That's a whole effort process that we need to take into account when we do evaluating language models, for example. Some of the token-based metrics are still valid in some languages of the East Asian languages, for example, Vietnamese. So we Vietnamese still think in the way that we count the word, we not count a character. And if the character stand alone, it doesn't make a lot of sense. But in Japanese and Chinese, think about it, the character can stand alone and it still can still be meaningful. But when they come together, they mean different things. That's also tricky. But that's something we need to bear in mind. The last point I want to mention is actually optimizations. A lot of we just go through, not very quite quick, but I just go through some of the very modern and kind of advanced technique that in the NLP community that I try to mention, and they try to develop recently related to NLP. But because in our team we also have a job that we need to optimize it on a mobile platform. So it's also very tricky problem. So when you, for example, that I just mentioned, character-based model, when it comes with the attention mechanism, that we normally is state-of-the-art, of course, but when it's come to the place, very costly to train, and the model can be very big. So the problem is that how can you fit that in a mobile, in client is also important. So it's also a discussion whether we want a cloud prediction or we want on-client prediction, or we can try to do pre-trained models. So I think if you work in NLP, so you know that recently people mentioned a lot about BERT. So BERT is also the state-of-the-art of Google, that they use pre-training models that have a lot with all the kind of optimization problem, but it also we need to optimize BERT on the mobile platform as well. A lot of papers that's going around and how you optimize BERT and then feed it into a mobile client, pulling the deep neural network and do other things to fit it into a mobile client. It's also a discussion that's why we don't use cloud predictions. There's a lot of reason around why cloud predictions is also quite limited. First of all, is privacy. A lot of data that, especially timing data, is very sensitive and very PII. So this is something that personal identifications, identifiable data that you cannot send to the cloud. So you need the consent of the people that you can send that into the cloud. So a lot of them you need to pre-train the model and feed into a mobile clients. That's the thing. And also, there's a lot of things going on, the differential privacy that you heard around. So, so that also a challenging problem in NLP, that you need to pre-train the model, fit it on client, or try to fit up, like try to balance between the cloud prediction and on-client pre-trained models. I think that's it for me. I don't want to go too deep into some of the technical detail, but if you want me to go further deeper into any of the slides that you want to discuss more, so just, feel free to to shoot any questions.
I got a question.
Yeah.
So the backstory is I'm a